This is lecture video 5 for section 5.4, video 4. So this is the last video. So here in this video, I'm going to demonstrate two examples how to use sum and difference identities to verify identity. So the first one we have is we want to verify, the title is we want to verify that following equation is an identity. So the first one we have is secant of pi plus x equal to negative secant of x. So to do this one, we always, or to do verifying identities, we always start from the complex side. The left hand side is more complex. So this is where we're going to start it from. So the left hand side equals to, I'm going to I want to expand it. So I want to use the cosine of a sum. Cosine of a plus b equals to cosine of a cosine of b minus sine of a sine of b. I want to use this formula. However, I can't because I do not have a cosine, I have a secant. So first I'm going to rewrite the secant in terms of cosine, that is 1 over cosine of pi plus x. Then I can expand it, but only the denominator. So everything is under the 1 over cosine of pi, cosine of x minus sine of pi, sine of x, where cosine of pi is -1, and then sine of pi is 0. So when I simplify it, I got negative cosine of x, where now I can rewrite it in terms of secant, which is equal to the right hand side. Okay, so for this one, you can try to do secant of 3 pi over 2 minus x equal to negative cosecant of x. Does this identity or verify this identity? So the next example I have is cosine of 2x equal to 2 cosine squared minus 1. Just erase it so we have more room. Okay, so for this one, we want to verify identities. I do have a cosine. There's no secants. That's good. However, I have a 2x. So for this one, even though 2 cosine squared x minus 1 looks more complicated, but cosine of 2x, I can rewrite it as cosine of x plus x. So that kind of give me the hint that I can using the sum formulas. So I'm going to start from the left hand side. So again, the sum formula is cosine of A, cosine of B, minus sine of A, sine of B. So we got cosine of x times cosine of x minus sine of x times sine of x. So I end up with cosine squared minus sine squared. Comparing what I have with the right hand side, I see I have 2 copies of cosine squared and then no copies of sine squared. So the second identity I'm going to use is sine squared x plus cosine squared x equal to 1, which means sine squared x equal to 1 minus cosine squared x. Okay, do make sure you have the parentheses around 1 minus cosine squared x because we have another negative sign in front of it. So it will distribute it into the whole expression will become to minus 1 plus cosine squared x. So at the end, I will end up with 2 copies of cosine squared x minus 1, which is equal to the right hand side. So for this one, you can try something very similar. which is cosine of 2x equals to 1 minus 2 sine square x.